Okay, we are going to be starting Chapter 7, which is all about polynomial functions. And you've had some work with polynomials back in Algebra 1, so we want to remember some of that stuff, use it, and move forward with acquiring more knowledge about polynomials. So, knowing that, we're going to be able to identify, evaluate, add, subtract polynomials. So by identify, we're talking about its name, what kind is it, size, and then classify the polynomials and describe the shapes of their graphs. So if you haven't, let's begin here. I believe I have several different names of polynomials and vocabulary words, so you've got all those there. So we're just going to have, I'm going to reveal, they're all stored right here. So let's see, the degree of a polynomial. So if you start looking at all the choices here, the degree of the polynomial, is it, and look at the different colors, the degree of the polynomial is the highest degree of all the terms of the polynomial. So when you heard about degree of a polynomial before, hopefully that's what it is. These must have gotten a little bigger or something. There we go. All right, so if we take this trinomial, a 3-term, 2-term, number of no variables, I think most of you said it. Ooh, these need to be locked. We got a trinomial, a 3-termed polynomial. Next one, a binomial. That binomial is, most of you know, a 2-termed polynomial. That should have come from your work in algebra. Hopefully those are terms we're remembering. If not, good thing we're reviewing. Next we've got a polynomial, a number in front of the variable, the sum of the exponents, a number or a variable or the product of both, a number with no variable, 2 or more monomials added together. That might be a good definition of a polynomial. Poly meaning many. Next word, what comes out? The degree of a monomial. A number in front of the variable, the sum of the exponents of the variable, a number or a variable or the product of both, a number with no variable. I like the sum of the exponents of the variables, degree of a monomial. So you're going to look at each term and you're going to figure out what they are. So we'll go back over here shortly. In coefficient, a number in front of the variable. We've been using that already in our earlier chapters. Next, we've got a constant, a number with no variable. There we go. It always has its constant value. And that leaves a monomial, a number, a variable, or the product of both. So when we start looking back at these, we definitely need to know them and know them fairly well. A couple things here, maybe we'll be doing it on the next example, but let's raise this up for a minute and just go over a couple of these terms. If I were to write the expression 3x squared plus 2x cubed plus a negative 4xy minus 3 plus 2x. If that was my polynomial that I was working from, then we could call the 3, the 2, the negative 4, and the 2 coefficients. They are the numbers in front of the variables. Then the sum of the exponents of the variables, so for each term, and you look at each term by itself. So I'm going to highlight, there's a term, there's a term. So notice, wherever the pluses and minuses are at, that separates it into terms. So we have 1, 2, 3, 4, 5 terms, which is a polynomial, and the sum of the exponents of the variables only is the degree. So this is second degree. This is third degree. This is second degree because we've got really a 1 and a 1 sitting right there, 1 on each x and y. We got 0 degree on the 3. There are no variables. And we've got a 1 down here on the term 2x. A number, a variable, or the product of both is a monomial. So 3x squared is a monomial, 2x cubed is a monomial, negative 4xy is a monomial, the negative 3 is a monomial, and the 2x is a monomial. What I don't have up there is just maybe just like y, just a variable. Variable is considered a monomial also. A two-term polynomial, if there were only 2 of these terms here, we'd have a binomial. A number with no variable, that was our constant. Our constant was the number negative 3. 2 or more monomials added together, polynomial, that's what this whole entire thing is. And then the highest degree of all the terms of the polynomial would be the degree of the polynomial. And if you look at ours again, it now goes, if I added this y term, and it would be a first degree. And we would have first degree, second, third, second, 0, and 1. So this degree of the polynomial would be a third degree. Notice it's not in order. We could rewrite it in order. It didn't ask us to do standard form here, but that's what that's about. So knowing that, we classify by that degree. If we had a third degree, then you should know these terms, and all it's saying is basically whenever you have a highest degree in your equation, whatever's leading off, and you might have other terms in here, and you put it in standard form. So if this is standard form, and the highest term is just something that has no variables in it, it's said to be constant. We've already done our linear ones, y equals mx plus b, our highest degree is a 1. Our quadratics, we've had a little work with them. They would have a degree of 2. Our cubics would have a degree of 3. Quartics would be a 4. Quintic would be a 5. We could keep going. But for right now, that's just what we're talking about. When we say name it, classify it, it would be a linear, so you're saying the polynomial's degree by saying that name. Okay. We will be doing some adding, subtracting, different combinations here. So let's just go to this example. If we talked about, we have an annuity, $1,000 invested at the beginning of each year in an account that pays 5% interest compounded annually for 4 years. How much will the investment be worth? Pays 5% interest compounded annually for 4 years. How much will the investment be worth at the time the last payment is made if the annual interest rate is 7%? Okay, so why did I have up there that it's 5%? So let's clean this up. Consider an annuity of $1,000. But the difference will be ours is now 7%. Okay, so I think we should be good. So they were basically saying in the lesson that if you did the first year, that'd be $1,000 times 1.05 to the first. And then after the second year, 1.05 to the second. Third year, 1.05 to the third. So if ours is now 7%, we need to make sure we put a 7 in there for our percentage rate, our growth factor. But we need to start off with the amount in our account will be equal to our initial deposit times our growth factor, 7%, so 1.07, compounded annually, so I don't need that divide by factor. And we said at the beginning of each year for 4 years. So we should be calculating something like that. And it's basically saying it's going over and over, repeating this process, which would give us a 4th degree polynomial. All right, if you did that, I hope we're getting $5,750.74. So calculate that and see if that's what you got. So a polynomial equation that was basically a word problem. Now, you've also done in algebra finding the sum, finding the differences, finding the product, finding the quotient. This one is an example of the sum, and remember when you're summing, when you're adding, you're looking for like terms only. So you have to decide how you're going to find those like terms if you like to do what we call the underlining process. This is just add the two. So I'm going to look at any third degree equations. I found two. Then I'm going to look for any second degree and underline them slightly differently. Then I'm going to look for the first degree. I only see the one, so I'm not even going to underline it. And then I see the two constants, which are the same. So I know I have some things to do. And so we want to write this in descending order whenever possible. So here we go. Let's go with our highest degree terms first. I have a 6x cubed added to a 2x cubed, 8x cubed. With a 3x squared and a negative 5x squared, you get a negative 2x squared. Add the negative 3x, which had no like term, a single term, and then we had our 10 and our negative 4. You could say negative 4 plus 10. Either way, we're going to end up with a polynomial in third degree, so a cubic, 8x cubed minus 2x squared minus 3x plus 6. And find the difference, done the same exact way, but remember with the difference you have to really pay attention to that sign and subtract whatever's there. So again, watch how I do this one. If I do my underlining, I only see one cubed term, but then I see a squared term here and a squared term here, and then again it's some constants. So here we go. We're going to start with our highest degree term first. That would be our cube, but it's none. There are no q terms here, but if you subtract a negative, we would get a positive 8x cubed. Then we're going to do the squared terms. 5x squared minus 1x squared is 4x squared. Then we go to our single degree terms, which is our 6x, and 6x take away 0 is just negative 6x. And then negative 11 minus 2 is negative 13. And so when we finish, again, we have a cubic third degree polynomial remaining, 8x cubed plus 4x squared minus 6x minus 13 as our result. Okay? Now, we may have done a few of these problems one day and a few the other, but the vocabulary is big, standard form, writing things in descending order, being able to classify the degree and the number of terms you have, and then being able to work with sum and differences. That's what our goal is for this first section. A lot of it is review from algebra, but necessary review that we need to hit. Double check with me if you have any issues with vocabulary when we come back to class.